Hey everyone, I've been wanting to try this laser surveillance or laser microphone project for a while and finally got some time tonight to give it a shot. So the idea is that you set up a laser and bounce it off the window of a house or a building, and any sound vibrations inside the room will cause the window to bend very slightly, and if you can catch the laser beam's reflection, you can demodulate the beam's wavering back into sound, so you can listen in on what's going on inside the room. Sounds very simple, and I gave it a shot. I set it up a 5 milliwatt helium neon tube on a tripod and aimed it at my dining room window, which is about 125 feet away from the shop. And luckily the geometry here works out pretty well, so the return laser beam was reflected back towards the shop, and I probably only had an angle of maybe 10 or 20 degrees input to output angle on the window. So one other unfortunate setup for this experiment is that the windows are all double paned in my house, which is actually very nice in terms of heating bills and sound isolation, but for this project it's not so good. So take a listen to what I got back. So to simulate voices inside the room, I used like an audio commentary track off the end of a Jethro Tull album, and used a sound meter to get about 70 decibels of average volume right near the window where this was happening. So it sort of approximates actual conversation in a room.
And Barry did. We were always on that dreadful South Circular, and we always got there sort of office hours, so it's the worst traffic, the worst journeys, with the big lorry drivers swearing at you as in my Glen G.
And like I say, the double pane effect definitely causes some strangeness in the return audio. There's sort of a whistling or a humming noise, which I'm betting is the resonant frequency in the cavity between the two windows. And you know, the way that my house is set up here, it's difficult to try a different window. Although I think I'm going to either set this up out at the street or something, or move to the side of the house, because I think I want to try a much larger window. The window that I was using is only about 12 inches on a side, just about. It's a French door type window. The receiver is very simple. This optical detector is a Hamamatsu S7815, and it's just a photodiode with some integrated amplification circuitry. And all I have is a 9-volt battery, which I covered with foil just for shielding, and it's connected basically right to the microphone input of my stereo. So the battery just provides a bias voltage for the diode. It's reverse biased with about 9 volts. And it goes right into the microphone jack on the stereo. So another problem I ran into is that the bushes were kind of in the way between here and the house. So if my neighbors didn't think I was weird enough for traipsing back and forth in the night with this laser, I also had to get out the hedge loppers and cut off some branches that were in the way. So I'm not sure what they think of me now, but well, whatever. So the system essentially works, and I'm fairly certain that with a single paned window the audio fidelity would be quite a bit better. Maybe I'll try even just putting a sheet of glass near the doorway or something just to simulate a single pane window. But anyway, what I really wanted to test was to sort of improve the whole system. So one of the problems with this is that you have to have the geometry. If you really want to perform surveillance on a window, you need to have geometry set up so that the incoming laser beam and outgoing laser beam are both accessible. So if you have a sort of a shallow angle, like 10 degrees or something, it works out okay, but then you don't really get as much deflection in the audio in the beam. So obviously at 0 degrees, the beam would just go straight in and straight back out, and I don't think that would work at all, although there are better laser microphones that make use of interferometry to make this work a little bit better. It uses a reference beam and all kinds of stuff to make a differential measurement on the window. And I'll put some links in the description. But anyway, my idea was to shine a laser beam into a room and then reflect it off of like a glass picture, like a framed picture that's hanging on the wall. And then you could use the telescope to look at the reflection that's appearing on the wall somewhere else in the room. And by watching the wobble in the reflection, you could recover the audio based on how the audio is shaking the framed picture, the glass picture on the wall. So I tried this out tonight and really didn't get anywhere. The dot was quite large. I'm not sure why the spread on that 5 milliwatt laser tube was so high. I seem to remember it being much better. But anyway, the laser dot was a good 2 inches in diameter, and it's only 150 feet away or something like that. But in the telescope, it looked quite nice. I also tried just looking at the 10%. Glass is about 10% reflective usually if it's uncoated. And if it's dusty, it's quite a bit more reflective. So I tried looking at that with the telescope too, just the reflection off the window. And I could see it in the telescope just fine, but with my optical sensor here, I didn't really pick up any recoverable audio. So I think what I'm going to try next is a little bit more of a sensitive optical detector, maybe a photomultiplier tube with a low voltage, because it's too much light for a photomultiplier tube. Maybe if I just used a low drive voltage, it would be okay. I think this has the potential to work. I probably should sit down and do the geometry to see how much beam wobble there actually is. So in a typical setup, the path length between a framed picture on the wall and the wall itself maybe is only 5 or 10 feet or something. And so the deflection of the beam is probably going to be measured in well under a millimeter, probably 100 microns or something like that. So maybe it's not even feasible to do this, but I thought it was worth a shot. And I'll be trying maybe some of the other interferometry techniques. I've got a friend that's pretty interested in this too, so hopefully we can get something going that isn't so dependent on beam angle. And we'll report back. All right, let me know if you have any suggestions, and I will see you next time.